it's Mr. Luneski with the last video of Unit 8. We're looking at Section 4, Geometric Mean and Special Right Triangles. So let's get started, what all this is about. What is a geometric mean? The geometric mean of two positive numbers, some two numbers, a and b, is the positive number x that satisfies the following conditions. If I set up some fraction of a number divided by x, that it is equivalent to that number x divided by b, or x squared is equal to a times b, or I can say that the geometric mean x is equal to the square root of a times b. So let's take a look at an example problem here of kind of how we would find a geometric mean given two numbers. So if I give you these two numbers and say find the geometric mean, the easiest part, I think, would be to just take these two numbers, so this is a, this is b, and basically we're just substituting them into that equation right there. And so I can say that x, or the geometric mean, is equal to the square root of 12 times 27. 12 times 27 is equal to the square root of 324, which that ends up equaling 18. And so the geometric mean of 27 and 12 is 18. The next problem here, we have what's the geometric mean of 16 and 18. 16 and 18, so again, we're just using the formula x equals the square root of a times b. This is a, this is b. Multiply those together, that gives me 288. And depending on what type of student you are, you can either just give me the decimal for that. So the square root of 288 is 16.97 roughly. So maybe round that to about 17 actually. Or if you wanted to simplify this in radical form, this breaks up into 144 times 2. Square root of 144 is 12, and then the square root of 2 stays as is. Alright, and the last one, kind of one of those weird ones with all the radicals in it. So you're still just doing a times b. So you can do x equals the square root of 8 times square root of 6 times 3 square root of 6. So remember the rules here, that we're kind of going to ignore this part at first, and we're just going to do 8 times 3. So 8 times 3 is 24. The square root of 6 times the square root of 6, you can actually type that into a calculator. But the square root of 6 times the square root of 6 is actually 6. And so now to simplify this further, 24 times 6 is equal to 144. And then the square root of 144 is 12. So that's my answer. One other type of problem that we can look at is, instead of me giving you two numbers and you finding the geometric mean, is if I give you the geometric mean, in other words, I give you x and ask you to find a or find b. So this one's saying 15 is the geometric mean, so that means x equals 15. And then it says of 25 and what other number, so 25 can equal a. And then we're solving for b. That's what we're looking for. So if you take a look at our equations up here, we can kind of pick any one of these equations to work with. So the easiest one that I think to work with for this particular problem is actually this. And so we can say x squared equals a times b. So we can say 15 squared equals 25 times b. And then from here, it's just a matter of solving for b. So 15 squared is 225. And then we divide both sides by 25 and get that b is equal to 9. So the geometric mean of 9 and 25 is equal to 15. So what exactly does all of this have to relate with geometry? Well, if we have a right triangle, triangle ABC, and let's say that the right angle is here, we can draw what's called an altitude down from the right angle and create what's known as three sort of similar right triangles. So we have this big right triangle, we have triangle A, and we'll just call this D, ADB, and then we have right triangle ADC. So we have three sort of working right triangles. And so the geometric mean, it's called the altitude theorem, is this. So we just drew this line down here, and this is my altitude. So I'm going to call that x. And all we're really going to do, and actually I'm not going to call that x. I'm a liar. I'm just going to call it AD, side AD. To find the altitude, we're going to do a geometric mean where we kind of make an upside down T. So we're going to say C to D is A to D. So CD is to AD. And then we just go back down. AD is to DB. So we're sort of setting up a proportion very similarly to how we did in Unit 6. So we're going to kind of just use that proportion there. So it might not make sense right now, but once you see it in a problem, you'll kind of go, oh, okay, I get that, hopefully. All right, so from here, we want to solve for E. So in order to do that, we're going to do our geometric mean, our altitude theorem. And the pattern that you sort of draw on the triangle, I always sort of relate to it as like a heartbeat, that it kind of goes up, it spikes, and then it comes down and flattens out. So that's all we're doing. We're saying 6 is to E as E is to 24. And if you notice, back at the beginning, that looks like A over X equals X over B. It's kind of what we've got going on here. This is A, this is X, and this is B. So now we just cross multiply and solve. So when I cross multiply, I get E squared is equal to 6 times 24. Whoops. And so 6 times 24 is equal to 144. So now I have E squared equals 144. Square root both sides, I get E is equal to 12. And then for this problem here, same thing. We're just sort of drawing our upside down T. So we'll say X is to 8 as 8 is to 4. And cross multiply and solve. So 4 times X equals 64. And then here, notice we don't have to square root, so that's kind of nice. We get X equals 16. So that's basically what you need to know for geometric mean, is just kind of follow that little heartbeat pattern like that. All right, the next little topic here is special right triangles, and we're going to kind of go through this a little bit quickly. Because the nice thing about this is if you forget it all, you can always fall back on your trig ratio knowledge. So there's two types of special right triangles. There's a 45, 45, 90 triangle, and that's basically referring to the angles inside of the triangle. The ratio of the sides follow 1, 1, and square root of 2. In other words, if you remember when we did those triangle problems, it would be like a variable, how I used to say slap a variable on it. It would kind of look like this, a times the square root of 2. And so what we're kind of looking at is a shortcut. Instead of doing all the messy trig ratio stuff, these are shortcuts that you can use for these two particular types of triangles. And so it says here that, remember, this is an isosceles right triangle, so the two sides opposite 45 degree will always be the same. So in a triangle, if I have a 90 degree and a 45 degree, this has to be 45 degrees, making it isosceles. Therefore, these sides have to be congruent. So that's why you see A. So down here, the way that I kind of do these problems is I always set up my triangle. So I'll say, okay, this is 45, 45, 90. And then opposite those sides, we have our ratio A square root of 2. So that's what these are, A square root of 2. And now I just fill in what information do I know. Well, I know opposite a 45 degree angle is Y. I know opposite the other 45 degree angle, which is here, is 9. And then over here is X. So the idea here is that you always want to solve for A. Because once you know what A is, you basically just fill in A and say, oh, well, A are those things. And so the way that this little box here works is you kind of think of it as an equal sign. That these two things here equal each other, and these two things equal each other, and these two things equal each other. So right now, I can say A equals 9. So if this thing is equal to 9 and a equals 9, now I just fill in. So if this is a, then y has to equal 9. Because again, this is isosceles, so if this is 9, this is 9. And then this side here is a square root of 2. So I fill in a square root of 2. Now again, if you don't understand that, that's okay, because you can always just fall back on your trig ratio stuff. On this situation here, whoops, I forgot to write in the actual angle. So notice, now I didn't actually give the angle for a reason. Both of these sides are the same, therefore you assume it's isosceles, therefore both of these have to be 45. So once again, I would say 45, 45, 90, a square root of 2. I know in this case, a, or opposite the 45-degree angle, is 6 square root of 2. And so a equals 6 square root of 2. And so now I just need to fill this in for a right here. Now notice it's still a squared times the square root of 2, so I have to do 6 times the square root of 2 times the square root of 2. This calculates to 6 times 2, which is 12. So my answer for x here is 12. Now again, you can just do a trig ratio and say, opposite hypotenuse. Sine of 45 equals opposite over hypotenuse, and still solve for x. These are just shortcuts. Shortcut, if you're given just the hypotenuse of 45, 45, 90, the missing side will be half of the hypotenuse. So on a situation like this, if the hypotenuse is 10, all of these sides are marked congruent, therefore it's a 45, 45, 90. If I wanted to solve for x, I'm given just the hypotenuse, so the missing side will be half of the hypotenuse. Half of 10 is 5. And then, whoops, I forgot to add to this. You also have to multiply it by square root of 2. So this should actually say the missing half of the hypotenuse times the square root of 2. So half the hypotenuse times square root of 2. Okay, one last thing is 30, 60, 90 triangle. This again refers to the angles, 30 degree, 60 degree, 90 degree. The ratio for 30, 60, 90 follows the ratio of 1, the square root of 3, and 2. Or, in our case, a square root of 3, 2a. And so here, opposite 30 is a, opposite 60 is a square root of 3, opposite 90 is 2a. So we're just going to quickly, again, do some problems. And remember, you can always fall back on trig ratios. So if you don't understand this stuff, it's okay. You can just do it how we've been doing it sort of, in class. So this is saying solve for the missing side lengths. So essentially, I'll call this x and y. So what I like to do is I like to set up 30, 60, 90, and just reiterate what my ratio is. A square root of 3, 2a. And then I know this is 30 degrees. So opposite 30 degrees is 5. So remember, you always want to solve for a. That's an ugly 5. Okay, so I know in this problem that a equals 5, because it's right across from 30, and 30 is a. So a is equal to 5, so now to solve for these two missing side lengths, what's across from 60 and what's across from 90, I just fill in 5. So this one would be 5 square root of 3, and then this one would be 2 times 5. My 5s are not looking good today. I apologize. And then 2 times 5 is 10. So I know that the hypotenuse would be 10 and that the side opposite 60 would be 5 square root of 3. This one here, kind of similar situation, 30, 60, 90. I'm going to say a square root of 3, 2a. What's opposite of 30? X. What's opposite of 60? This would be 60. Y. What's opposite of 90? 32. So we want to solve for a. So in this problem, 2a equals 32. Because remember, these two things equal each other. So now I want to solve for a. So I divide both sides by 2, and I would get that a is equal to 16. And so now I know what a is. Now I just plop it in right here and put it right there. So x would equal, or this side right here would equal 16, and this side here would equal 16 times the square root of 3. And you can just leave it in radical form. You don't have to do the decimal stuff. Alright, and then the very last problem here, we have 30 degrees here, 60 degrees here. I'll call this x, I'll call this y. 30, 60, 90. Whoops. A square root of 3, 2a. So, what's opposite of 30? X. What's opposite of 60? 4 times the square root of 3. What's opposite of 90? Y. I want to solve for a. That's what I want to do for all these problems. So if I look at this ratio, if you notice, they both have a square root of 3 in it, so a is just this. So a equals 4. Therefore, x equals 4. Y equals 2 times 4, which is 8. So x equals 4, y equals 8. As a reminder, if you did not get the 45, 45, 90, 30, 60, 90 triangle stuff, it is okay. You can always just fall back on your trig stuff. So instead of doing all of this little shortcutty stuff, you can just say, to solve for x, that this is opposite over adjacent, and you can say tangent of 30 equals x over 4 times the square root of 3, and then solve for x just like we've been doing since 8.2. Okie dokie. Thank you for watching. Have a wonderful day.